Hi all, I am Sumina MS. Today we are discussing about Stern-Gerlach experiment. So we can begin with a brief introduction of Stern-Gerlach experiment. As by the name we know that the Stern-Gerlach experiment was performed by German physicist Otto Stern and Walter Gerlach in the year of 1922. They demonstrated that the spatial orientation of angular momentum is quantized. Through the experiment, they also confirmed the presence of electron spin into two orientation and also its space quantization. Through Stern-Gerlach experiment, they illustrate the fact that an electron possesses an intrinsic spin which imparts it an intrinsic angular momentum, and this angular momentum is called spin angular momentum. Through the experiment, it also proves the space quantization of spin magnetic moment. The Stern-Gerlach experiment was made a major contribution to the development of quantum theory of atom. Now we can see the experimental setup of the Stern-Gerlach experiment. In the experimental arrangement, we can see a hot oven which contains silver atoms. There is two collimating slits. We also use a non-uniform magnetic field, and there is also a screen which is a photographic plate which record the beams. Here a well-defined beam of silver is obtained by evaporating silver in a hot oven. Then they directed the beam of neutral silver atoms through the set of collimating slits into a non-homogeneous magnetic field. The non-uniform magnetic field is produced by a pair of pieces in which one of which has very sharp edge and other has a grooved face, and which exerts a net force on the magnetic moments of the atoms. Now we are using non-uniform magnetic field. This is to change the direction of silver beam. The field acts perpendicular to the direction of motion of the beam. The collimated silver beam is heading in y direction and the non-uniform magnetic field is acting along the z direction. So they are mutually perpendicular to each other. The emergent beam then strikes the photographic glass plate which records the configuration of beam after it passes through the field. In the experimental observation, we can notice two types of observation depending on the magnetic field used. In the first case, when the magnetic field used is uniform or the magnetic field is not applied, the dipoles merely experience a torque, and the result is a thin fine line in the shape of a slit is obtained on the photographic glass plate. And in the second case, we are using a non-uniform magnetic field, and then the beam is found to split up into two components, resulting in two distinct traces on the given photographic glass plate. The two major points that we have to discuss in this Stern-Gerlach experiment is, first, why silver atoms are used here. This is because the atomic number of silver is 47 and its electronic configuration is given. Here all the 46 electrons are paired except the electron in 5s subshell. So we can see it has unpaired 5s electron. All other electrons are paired so that the total angular momentum is 0 since it cancels each other. The 5s electron has 0 orbital angular momentum and also it has 0 magnetic moment. This is given by L is equal to 0. Spin at unpaired 5s electron gives a magnetic moment here. The net orbital magnetic moment of each silver atom is 0. Hence, the beam should not experience any force in the presence of the given non-uniform magnetic field and should not get deflected. But actually, this is a contradiction to the experimental results. So, it cannot be explained on the basis of orbital angular momentum alone. And we can discuss why we are using a non-homogeneous magnetic field here in this experiment. This is because here each dipole experiences a force which can be written by equation F in Z direction, force in Z direction equal to minus dou U by dou Z, where U is the potential energy of silver atom. We know that force can be expressed as varying potential energy. Force varies with the orientation of dipole. In this case, each silver atom in the beam acts as a tiny bar magnet with certain magnetic moment. This magnetic moment experiences a torque when placed in non-uniform magnetic field, which tends to align it along the direction of applied field. So we are using a non-homogeneous magnetic field here. After all, a satisfactory explanation for Stern-Gerlach experiment results was given by Goudsmit and G. Uhlenbeck in 1925 when they introduced the concept of electron spin. They also suggested that the electron has spin motion apart from its orbital motion. This is due to the spin motion that the electron possesses an intrinsic spin magnetic moment in addition to its orbital magnetic moment. Therefore, net angular momentum and magnetic moment in silver atoms comes from spin of its valence electron, that is the outer electrons. Now, when the silver atoms are made to pass through a non-homogeneous magnetic field, they experience some kind of force due to their net non-zero magnetic moment. And experimentally, this beam splits into two components, which is explained by quantum theory, and this is due to the space quantization of the spin magnetic moment. Now we can discuss about the quantum mechanical explanation of the Stern-Gerlach experiment. By quantum mechanical explanation, when silver atoms pass through a non-uniform magnetic field, the field will have two effects. First one is the magnetic field will exert a torque on the magnetic dipole such that magnetic moment will process about the direction of magnetic field, that is along the Z axis. Z component of nu vector will remain constant, but x and y components of nu vector will change with time. We know that. In the second case, the second effect is more important, and this effect leads to the experimentally observable results of Stern-Gerlach experiment. Due to the non-uniformity of the applied magnetic field, we know that atoms experience a force in which direction it is along the Z direction. And by the equation, Fz is equal to minus dou U by dou Z, where we know that U is the potential energy of silver atoms in the magnetic field. This potential energy can be written as minus nu dot B vector is equal to nu B cos theta. Now we can write nu cos theta as nu Z, nu along the Z direction. So the equation will become U is equal to nu Z B. Then our equation Fz can be written as minus nu dou B by dou Z, where dou B by dou Z is the gradient of magnetic field. We can also observe that the silver atoms arriving on the screen formed has two traces. We already see that in the experimental observation. This is because when the silver atoms enters the non-uniform magnetic field, we already said that it experiences a force whose direction depends on the orientation of its spin magnetic moment. So this orientation, it has two orientation is possible. Only two orientation is possible. The two possible orientations are given by the spin magnetic moment. Ms is equal to minus 1 by 2, which corresponds to spin down, and the other is Ms is equal to 1 by 2, which corresponds to spin up. And this is the quantum mechanical explanation of Stern-Gerlach experiment.